Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 5E assignment. Okay, first one we're going to look at, number 1, match each scatter diagram with the correct rank scatter diagram. Okay, so we can tell here that the rank of X1 is going to be the lowest rank of Y, so it's going to basically look like something that goes down like this. This doesn't have much correlation. This looks like it's a pretty good, strong correlation. And it starts to kind of get a little weird in here where you've got some higher ones as you go farther out. So this one is definitely going to be B. Okay, if this was like a line that was going straight up and there's no like weird points that were falling up or above that, then that's going to be this C. If it doesn't have really any relation, then it's going to be this one here. Okay. All right, next one, number 4. In a 60-minute art lesson, students were asked to make as many paper cranes as possible. It shows how each student to make a paper crane and how many cranes they made during the lesson. Okay, draw a scatter diagram for the, okay, let's get ourselves a scatter diagram here. Okay, so this is our X and this is our Y. X is time, Y is cranes made. So it looks like we're anywhere between 4 and 11. Okay, so this is 20 long, so let's just start this with 0 and then we'll have to go up by, I guess we go up by ones. I really don't like that because I really want 11 is going to be barely past the halfway, so let's start with this at 0, and then how about every 3 lines we'll do 2. 1, 2, 3, so that's 4, 6, so forth and so on. And that is 12. Okay, so that at least kind of gets us, it just kind of gets some more of our data over here into this half here. Okay, on this one here, lowest one is 4, highest one is 16. So 16 gets us pretty well up there, so we can just do excuse me, do all these by ones. Okay, looks like that. So now we're just going to go through and graph. So we've got 6 and 9 here, and then we'll go through and graph all the rest of these as well. Okay, so that's kind of what our data looks like there. Draw a scatter diagram. Calculate Pearson's product moment correlation coefficient, which is the R value. So in order to do that, we're going to have to put all of our data here into our graphing calculator. Okay. Oops. All right, so we will get, we'll get all of our data in here. This is all the X, this is all Y. Okay, so here's all of our data. So we want to calculate the correlation coefficient, the R value. So go over to calculate, and it is the 4th one down. So you can push 4, or you can arrow down to that. Make sure that the frequency list is clear. Go down to calculate. And there's our line, negative 1.53 x plus 19.3. And here's our R value, which is what we're looking for, negative 0.921. Negative 0.921. Okay. Find the ranks for each of the variables and draw a scatter diagram for the ranks. So what we're going to want to do for that then there is I'm just going to, since we have room above and below, I'm just going to put each rank above and below. Okay. So if we look here, so we've got to look for the lowest number. So this is the lowest, so that's first. Second lowest is 5. Third, fourth, and then so forth and so on. And then we're going to do the same thing for this here. That's the lowest. That's the second lowest, so forth and so on. Okay, so here's our ranks for each piece of data. Okay, find the ranks for each of the variables and draw a scatter diagram for the ranks. So let's draw another scatter diagram just for the ranks. Okay, so X rank is 1, the Y rank is 8. So we go to 1 and 8. And then I'm going to find 2. 2 goes with 7. And then we will continue this and graph each and every one of those. Okay, and that's what our our rank scatter diagram looks for the ranks. Okay. So we've done those. Calculate Spearman's rank correlation coefficient. So what we can do on this one here is we can put it in to the graphing calculator. So we do, let's see, edit, and then we're just going to literally put in these data points here that we have. Right, so like this is going to be one. I'm just going to do, well, you could do 3, 6, 7, 2, 1, 8, 2, 7, so forth and so on. But I'm just going to do this. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8 on list 1, and then the corresponding one for that in the Y rank in list 2. So I put all the X's in. For the Y's, we know that 1 goes with 8, 2 goes with 7, 6, 5, 4, 3, 2, 1, 0. So these are pretty easy to put in. So we just do 8, 7, 6, 5, 4, 3, 2, and 1. Oh, I apparently didn't hit enter up here. Let's try that again. 5, 4, 3, 2, and 1. Okay, so now we can go into stat, calculate our linear regression, number 4. Go down, make sure that the frequency list is clear and the X list is list 1 and the Y list is list 2. Push calculate, and our R value is -1. Okay, R equals -1, which means it's a perfectly straight negative line. Now, we could have actually looked at this and said, oh, that makes a perfectly straight line, so it has to be +1 or -1, and since it's going down, it's got to be -1. So we didn't have to put that in the graphing calculator, but it's good to just know how to do that in the graphing calculator. Which correlation coefficient is more appropriate to use for this data? Explain your answer. So probably the big thing that we want to look at here is this makes a nonlinear trend here. So what we'll probably want to do is we're going to want to choose the Spearman's rank. Okay, so which correlation coefficient is more appropriate? Spearman's. And it's just because since our scatter diagram up here of our raw data is not linear, we want to use Spearman's. Okay, and then describe the correlation between the variables. So as time taken gets bigger, then the cranes made is smaller, which is hopefully pretty straightforward there. Okay, the correlation, if we're describing the correlation, that's how the two variables are related. So really we should say it is a very strong negative, and really what we're between the two variables, really what we're looking at is this graph up here. So it's strong negative and officially non-linear. Okay, this is linear, but that's the Spearman's rank. Whenever you're talking about the correlation between the variables, it's always going to be of the original raw data. Okay, all right, that's all we have here. Oh wait, I take that back. We got one more. I'm going to go over number 6 as well. Okay, 10 students in a typing contest were given 1 minute to type as many words as possible. Table below shows how many words each student typed and how many errors they made. Here's the data. Calculate RP and RS. So that's the R value for Pearson's, and then that's the R value for Spearman's rank. Okay, so the RP is just all this data entered in, and then the RS is the Spearman's is the rank. So really we can actually probably do both of these at once. So let's rank each one of these. Lowest one here is 20, and then we'll rank all of these, and then we'll also rank all of these. Okay, here's all of our ranks. The Y's worked out pretty nice, and up here in the X's we actually had 2 that were 35s. So that happened to be the second and the third. So what you got to do, so first one was 20, and then these were the next 2 smallest. So what you got to do is say, okay, one has to be second, one has to be third. So you go 2 plus 3, divided by 2. That's 5 halves. They're each 2.5. So 2.5 for this, 2.5 for that. So that's first, basically tied for second and third, tied for second and third. So then the next one's going to be 4, 5, 6, 7, so forth and so on. Okay, so now here's what we're going to want to do. Edit. Okay, now what we can do here, if you want, and you don't have to, but I'm going to do it just to be a little different here. So we're going to put all this data here in the X, the list, that's list 1. And then all this data is list 2. Okay, and then what I'm going to do is I'm actually going to go through and put all of this, all the Spearman's ranks into list 3 and all the Y Spearman ranks into list 4. Okay, and then I'll show you how we can, so then we only have to put all the data in once. Okay, and then I'll show you how we can calculate both from there. Okay, so list 1 is all my X's, list 2 is all my Y's, list 3 is my ranks for the X's, and list 4 is my ranks for the Y's. Okay, and remember we had 2 that were 2.5 on here. It does not matter which order those go in, because those are just data points. Okay, so now that we have this, it says calculate RP and RS. Okay, so RP is going to equal, and then RS is going to equal. So we can do Pearson's, that's just our regular R value. So we're going to use list 1 and list 2 there. So what we're going to do, stat, calculate, linear regression number 4, and then the X list is list 1 and the Y list is list 2. We didn't change anything there. Frequency list is still blank. Calculate, and we get our R value is 0.762. 0.762. Now to do the Spearman's rank on that is we're going to go back straight into stat, and we're going to go over to calculate again, and we're going to do another linear regression. So that's number 4. And then now the thing that's different is that this needs to be, our X list now needs to be list 3 and our Y list needs to be list 4. So I have to change L1 to L3. So what you got to do here is look in here, L1, L2, L3. So I have to turn this into L3. So I have to do second 3, and that'll turn it to list 3. And then for this next one, I have to do second 4, and that's now list 4. Now, this works. This is going to work out just fine, but one thing that's super important if you do decide to do it this way is I would suggest as soon as you're done, go back and change the X list back to list 1 and the Y list back to list 2. Okay? So we're okay to do this, and this gives us an R value now of 0.681. 0.681. Okay, draw a scatter diagram for this data and hence identify the outlier. Okay, before I do that, I'm just going to go back in here, stat, calculate for, and I'm going to turn this back to list 1 and list 2. So I'm just do second list 1, second list 2, and then I'm just recalculate, it's going to give us this same 0.762 back because it's recalculating this data here. Okay, it's just wise to do that so you don't end up forgetting and then messing up. It'll mess up something else later on. Okay, so scatter diagram for this data. All right, so let's do that. Okay, here's how we can set this up. Again, the way to choose your scale here is look at, this one goes up to 85 is the highest, 20 is the lowest, so I just decided to go each 2 lines to go up by 10, so that would get us up to 100. And then this down here goes all the way from 2 to 30, so I decided to have each one of these worth 2, so 4, 8, 12, so forth and so on. Okay, now we're just going to go through and graph, so we would go over to 40 up to 11. It's going to be halfway in between here. So there's that first point there. And we can go through and graph all the rest of these as well. Okay, so here's all of our data. So we drew our scatter diagram for this data and hence identify the outlier. Here's our outlier. All right. Recalculate RP and RS without the outlier. So we have to take out the point that is 35.27. So this here is our outlier. So we're going to get rid of that outlier, okay, from our data. So what we have to do is, if we're getting rid of that outlier, it's actually not too bad in our regular data list here with this 35 and 27 we got to get rid of, but it's going to make it a little bit more challenging. We have to re-rank everything with Spearman's. Okay, so here's what I'm going to suggest on this here. Let's see if this will even work, because I think if we delete it, oh, okay, good. Look, if we delete it, it just moves the data up. So that's good. So we can just delete those pretty easily. And then what we're going to do is we're going to have to go back and figure out what the new Spearman's ranks are without these numbers in there, because that kind of throws it off with this 2.5. So let's go through and figure that out. I'm going to put these new ranks here in red next to them so that we're good. So this one is now gone. So there's our first and second, and we can just kind of keep on going here. So basically this one got thrown out. So that means that all the rest of these are just going to be one less. So 3, 4, 5, 6, 7, 8, and 9. Okay, and then same thing here. This one gets thrown out. So the rest of these are going to be pretty close. That's going to be 1, 2, 3, 4, 5. Still 6, 7, 8. This 9 gets thrown out, so now this one is 9. Okay, so now that's our new Spearman's data. So now we'll update the our data here. Okay. So here's our ones, our 2.5 now. One of those is gone. And basically we got to turn this into 2, 3, 4, 5, 6, 7, 8, 9. So we're gonna have to. I'm gonna stop this and fix this all, so you don't have to watch all of that through. So I just fixed the 2 and the 3, and then we just want to delete the 10. We don't want that in there anymore. And then now we just got to realign all of these here to make sure that they fit. Okay, 1 goes with 1. This is now 2 goes with 2. 3 and 3. So 3 is now with 3. 4 goes with, oops, that looks like a 5. So 4 now goes with 5. So see how we have to kind of go back through and we have to reorder all these here. 5 goes with 4. 6 and 7. Let's see, 7 goes with 6. 8 goes with 8. And 9 goes with 9. And we no longer need this 10th piece there. So now we've taken out the outlier and re-ranked everything. Okay, so now it says recalculate RP and RS. So without the outlier, RP and RS. Okay, so let's calculate those out. So we're going to do stat. We're going to calculate the linear regression. So that's number 4. And then since we're going to do the Pearson's one first, we're going to leave list 1 and list 2 in there. All the way down to calculate, push enter. And that will give us our new 0.976. Okay, so now we are 0.976 compared to 0.762. So that's pretty significant. And then let's look at our Spearman's. We'll go back and calculate the Spearman's rank. So stat, calculate linear regression number 4. And now we got to change list 1 and list 2 to list 3 and list 4. So second, list 3, second, list 4, go down and calculate. And now our new spearman's rank is going to be 0.967. So you can see that had a big effect on both of those. It made it a lot better line with both of those. Okay. Which correlation coefficient is more affected by the presence of the outlier? This is 0.76 and changed to 0.97, so that's about 0.18, and this is 0.68 to 0.967, so that's really pretty close to the same not really, is it? So 96 minus 68 is going to be, what, like 28 instead of 18. So the Spearman's seems to have had a bigger impact. So correlation coefficient is, the Spearman's correlation coefficient is more affected by the presence of the outlier. So the RS. Okay. All right. Now that's these are the ones that have been chosen to have been shown here. So if you have any further questions on any of these or any ones that I didn't show on here, please feel free to ask. Thanks.